data that you've had. Okay. Just come up with a verbal description. So maybe you've heard a problem expressed in words, and you've got some numbers to go with it, and you want to come up with a formula to represent it. Or maybe you've got some words, and you can draw a picture of it, pictorially, verbally describe it. Maybe you could even take that picture and turn it into a graph. So in math, we're expected to be able to interpret between a picture and a table of values, between a picture and an algebraic expression, between a picture and a verbal description, between a picture and a graph. And I can say that again. We need to take an algebraic equation and graph it, an algebraic equation and come up with a table of values, an algebraic equation and verbally describe what would be happening in a real world context, an algebraic equation and just do a quick sketch of a picture like you were doing in the warm-up. Okay, and I'm not going to say it all 5 times for each one of them, but you need to be able to interpret in between any of them. So I'll point out how we're doing that as we go through the lesson today. Okay, so in Math 11, you studied parabolas and learned how to write them in standard form, as in y equals ax minus p all squared plus q. And it lets you find the center of the circle, or the vertex of the parabola. Okay, so for circles, we know we've got this formula, x squared plus y squared equals r squared, with a center at 0, 0, and a radius of r. So if I'm looking at x squared plus y squared equals 25, the center is at 0, 0, and the radius is root 25. So if I look at this circle, x minus 4, y minus 3 equals 25, the center is at 4, 3, and once again, the radius is 5. Let me give you an example with parabolas. If we start with a basic parabola, y equals x squared, would you tell me where the vertex is? Of course, 0, 0. If I change this equation, y equals x squared, to this, y minus 3 is equal to bracket x minus 4 all squared. And I asked you to write that in standard form, then you would move the 3 over and say this, y is equal to x minus 4 all squared plus 3. Tell me where the vertex is. At 4, 3. So notice this has a vertex at 4, 3, and this has a vertex at 4, 3. These are the same equation. Yes?
When you move y minus 3 over to the left, why did the square come in?
I didn't move y minus 3 over to the left. I moved negative 3 over to the right. I added 3 to both sides of the equation. Okay, so these circles, these 2 circles are the same size. This parabola has the same shape. It's just that the second one has been moved 4 to the right because x changed from x to x minus 4, and 3 up because y changed from y to y minus 3. Okay, so if x had changed to x plus 5 and y had changed to y plus 1, you would have moved the center to negative 5, negative 1. X plus 5 would have moved it 5 left. Y plus 1 would have moved it y down. That's true not just for circles and parabolas, but for every shape. So your whole catalog of basic functions can get shifted using these instructions. So we call these translation. So here's your definition. What is a translation? It is a transformation that slides each point of a figure the same distance in the same direction. So your shape is going to look identical. It's just going to have a different starting point. Okay, so in math, we often try to reduce something to a problem we've seen before, a previously solved problem, because then we know how to do it. So if you take something complicated, like a circle or a parabola that's not centered at 0, 0, vertex at 0, 0, and you shift it somewhere, well, if you shifted it back, then you'd know exactly how to graph it. So that's what we're going to try to do. We're going to try to see how the transformations, these translations, move any function. Okay, so we're going to start getting used to function notation. A couple of vocab words you're going to have to become comfortable with. I'm going to write 3 of them down. One is composition. One is explicit in a math context. And one is implicit. Okay, composition means we compose the function, meaning that whatever happened to your x value in the function has to be changed all the way through the function. Explicit function means it's the way you're used to seeing it. Y equals f at x. So all of your catalog of basic functions, except for the circle, are explicitly defined. Implicit is when you've got something complicated, like x squared plus y cubed is equal to 2x plus y. That's implicit because I can't just get y all by itself on one side and all the x's on the other. Okay, so we're going to keep talking not about y equals anymore, but f at x equals. So remember always that y is just the function at x. When you graph it, it's the y value that comes out.